in this video, we'll talk about evaluating functions, how we evaluate functions. Okay, so I'm going to get into an example right away, which says evaluate each expression for the function g of x equals x squared minus 4x. All right, so part A says do g of -5. Okay, so the way we interpret this is whatever is written inside the parentheses, in this case it's -5, that's what we get to plug in for the x. So in our equation, anywhere there's an x, I'm going to plug in -5. So I'll get -5 being squared, and then minus 4 times -5. And evaluating this, well, -5 squared, that's 25. And this double negative becomes a positive, I'll get plus 20. And adding those numbers together, I get 45. Okay, so that is 45. Okay, so the same thing applies even if the thing that I have inside the parentheses is a variable. Like over here, I have this a. Okay, whatever's in the parentheses, that's what I'm going to plug into my function where the variable is. So where that x is, I'm going to be plugging in a now. So that'll give me a squared minus 4 times a. And so I could write this more simply as just a squared minus 4a. So I don't really need those parentheses there. Okay, and one thing I want to mention is for b and c here, I am not gonna simplify them. So I'm simply going to plug in. I'm not going to simplify and factor them, because you might have noticed, wait, b factors a little bit more. Okay, all right, so what about c? All right, so even if I have a more complicated looking thing inside the parentheses, like x plus h, I could still do the same thing. So I take that whole thing and I'll plug it into my function wherever I see the x. So that'll give me x plus h squared, and then minus 4 parentheses x plus h. All right, okay, and that's it. I've plugged in the x plus h into my function wherever the x was. So that's my answer to C. Let me also box my answer to B. Okay, all right, so let's do a more complicated one. So part D. So this is an example of something that's called a difference quotient. Okay, it's a difference because on the numerator I'm subtracting 2 terms. And subtracting 2 terms, that's sometimes called a difference. And quotient means I'm dividing 2 things, and I am dividing 2 things here. Okay, so how do I evaluate something like this? Well, we just did g of x plus h. Like we just figured out, wait, g of x plus h equals all of this. So let's use that. So I know that first term in the numerator is x plus h squared minus 4 times x plus h. Right, that's just what we got when I plugged in x plus h into our function wherever the x was. Okay, so that's g of x plus h. Then I have that minus sign, and that's going to subtract what g of x is. Okay, so I got to subtract g of x. Oh, but g of x, I know what g of x is. G of x is this over here. So I got to subtract that. Okay, so I'm first deliberately going to write it wrong and see if you can catch my mistake. So when I subtract g of x, I have that minus sign, and then I'll write g of x, x squared minus 4x. Okay, let me highlight it just so I see that. Okay, that's g of x. Okay, and now do a quick pause, 20-second pause, see if you can catch what I forgot, what my mistake is here. And of course, you know, this whole thing is over age, but that wasn't my mistake that I wanted to talk about. So pause the video, quick 20 seconds, see if you can catch my mistake. 4, 3, 2, 1, pause it for 20 seconds, see if you can identify what I forgot. Okay, so what I forgot was I need to put a parentheses around this because this minus sign needs to apply to the whole g of x part. And if I don't have that parentheses, well, my minus sign would only have been applying to the x squared term, but not to the minus 4x. Okay, so I got this. And for part D, I do want to simplify this. So I'm going to specify right now that I want to simplify this. Okay, so what could I do to simplify it? Well, let's expand some of these things in the numerator. So if I do x plus h squared, if I FOIL that out, we get x squared plus 2xh plus h squared. And if I distribute that minus 4, minus 4x minus 4h. Then if I distribute that next minus sign, I'll get negative x squared plus 4x all over that h on the bottom. And now we get some cancellation. And this will frequently happen in these difference quotient problems. X squared cancels with the minus x squared, and minus 4x cancels with that plus 4x. Okay, now this is nice because the remaining terms in the numerator have something in common. So those remaining terms, they all have an h. So I can factor that h out, and that leaves me with 2x plus h minus 4 over that h on the denominator. This is now nice because now the h that I factored out of the numerator, that cancels with the h on the bottom. Nice, so that leaves us with 2x plus h minus 4. The one thing I have to make sure to write is that if there's something on the denominator like this that cancels away, I have to remember there's one thing I got to be careful about. What if that denominator was 0? Because that would make it undefined. And when I look at this simplified answer, I can no longer see that that was a problem. I can no longer see that plugging in 0 for h was bad before. So I need to make sure to remind myself of that restriction, that h is not allowed to be 0. So this is called the domain restriction. That needs to be part of my answer. Okay, so these difference quotients, they show up all of the time in calculus. In calculus, you'll be doing something called calculating a derivative. And to do that, we need to be able to simplify these difference quotients, which is basically just an algebra problem. In calculus, we will do one extra step at the end, which involves doing something called taking a limit. But to get us ready for that, we need to be able to simplify these, which is why we're going over it now.